Hi friends, today we will learn simplification techniques for block diagram. So if you have a system with a lot of interconnected components connected in series or parallel or feedback interconnected and so on, there are many methods where we could simplify and get the overall transfer function. There are few techniques like the signal flow graph methods. For these are very simple tricks which you need to learn, and I will quickly run through these tricks before we do some examples. But simplifying a complex system is tedious. Today we will learn how to do this with MATLAB. Before that, what is a block diagram? It is a shorthand representation of a system where you have each subsystem or each component represented. Here you can see a gain block, a transfer function blocks, a sum blocks, and a feedback log. And this system is perturbed with a step input, and the output is measured using scope. So here we can see that two blocks, they added together. So the transfer function is the 5 plus 7 divided by s plus 1. So 5s plus 5 plus 7, so it is 5s plus 5 plus 7 divided by s plus 1 is equal to 5s plus 12 divided by s plus 1. Again, that block is series with 1 by s plus 2. So again, this is multiplied with 1 by s plus 2. So the overall open loop transfer function of the system is 5s plus 12 divided by s square plus 3s plus 2. Let's see how to do this with MATLAB. Let's open the MATLAB. See, here I developed the block model in Simulink, and then on the input side just right click here and select the linear analysis point, select open loop input, right click, linear analysis point, open loop input, then move to the output side, right click, again linear analysis point, then open loop output, right click, linear analysis point, open loop output, then move to analysis tab, where you can see under the control system control design a linear analysis. Open that one, then click step. So here you will get the step response of the system, the step response of the given system. So here you can see a Lindsys 1. Just move this one to the MATLAB workspace, just drag and drop, drag and drop. Already a Lindsys 1 is there, it will override with this, so just drag and drop, then move to the MATLAB. So what is our function? Lindsys 1 transfer function, Lindsys 1. So the overall transfer function of the system is 5s plus 12 divided by s square plus 3s plus 2. Really, that is exactly matches with our result with pen and paper. So this is a very simple system, but when you do a very complex system, pen and paper may not work effectively, so you have to use MATLAB techniques to reduce the system. So the transfer function of the system is actually the open loop transfer function. It is not a closed loop transfer function, because we used linear system point, the open loop input. So the output is, the overall transfer function of the system is not considered this feedback loop. It is an open loop system. So the overall transfer function of the system is 5s plus 12 divided by s square plus 3s plus 2. That exactly matches with our result with the MATLAB. Again, there is another way. Without going to the MATLAB, you can find the transfer function. Just select this one and move to the plot result and result viewer, then select transfer function. Yes, here you can see that set from input u1 to output y1. The open loop transfer function is 5s plus 12 divided by s square plus 3s plus. This technique is nothing but the linearization of the system. The system is linearized. That means the system is reduced. So that is the end of this video. Watch next video to see how to obtain the transfer function of a closed loop system.